Hi everyone, in this video I'm going to talk about transformation of reciprocal function. So first of all, what is reciprocal function? In the part 1 we have seen the parent function for reciprocal function is f of x equal 1 over x. So this is your parent function. Now if you do some translation and orientation and shape, then it will give you the transformation of reciprocal function. So let's try to understand. If you have f of x equal a over x minus h plus k. Is this a reciprocal function? So obviously yes, this is a reciprocal function. Now what is h here? H representing horizontal translation. And what is k? K is representing vertical translation. So when I say horizontal, it means like this, and when I say vertical, then on y-axis like this. Okay, now if the h is positive, if h is positive, then you will move right. If h is negative, then you will move left. Okay, and x equal h will be called vertical asymptote. So right now just try to remember this information as much as you can, and after that I'll show you using the example how does these things work. Okay, now if k is positive, so what do you think, where will the graph move? If k is positive, then the graph will move upward, and if k is negative, then the graph will move downward. So f of x is equal k. This is called horizontal asymptote. Okay, at asymptote the graph reaches infinity. Okay, or graph reaches zero, but it doesn't actually touch zero. Now what is the a here? The a is the representation for the shape and orientation. Okay, so let me just remove this information from here so we can have some space. Okay, now a is the representation of orientation and shape. Now if a is negative, so if a is less than 0, then graph will be reflected across x axis, reflected across x axis. And if mod of a greater than 1, then graph is stretched vertically, the stretch vertically. So you can fast forward this information and you will be able to save some time here. If a is between 0 and 1, then graph is compressed. Then graph is compressed vertically. So how does these things work? We will see using some examples, but for now you will have to remember this information, that if mod of a is greater than 1, basically if negative uh, let's say negative 2, so this is more than 1, right? That's why it is mod. So this is more than 1, so it will stretch vertically. And if a is, let's say, negative 1 over 3, then it will be compressed. Okay, since it is negative, but then it will be reflected also. okay, that you need to remember. So these two things will work simultaneously in this case. Now let's try to understand some example. So first question we have, f of x is equal 3 over x minus 4 plus 2. Now let's try to understand the basic information here. First of all, if x equal 4, then the graph will be undefined, right? If x equal 4, then graph will be undefined. So x equal 4, is this horizontal asymptote or vertical? Try to recall. This is your vertical asymptote. Now what about k? Here k is 2. So f of x is equal k, and k is equal to positive 2, and this is your horizontal asymptote, right? First of all, you need to derive all the information from this. Now what is a a? A is 3, and which is more than 1, right? More than 1, so it will be stretched or compressed. It will be stretched vertically. Will there be any reflection? The original graph is like this, right? When I say reflection across x-axis, then it will be reflected like this, okay? This will come down and this will go up. Reflection across x-axis. So will it be reflexed? No, it will not be reflected because a is more than 1 and positive. Now what will be the domain and range? For that, let's try to understand using the graph. I can tell you without graph also, but let's see first of all the graph, okay? Okay, I will draw a rough graph, so don't mind if I won't be able to draw it properly. Okay, this is your x-axis, this is your f of x or y-axis, okay? Here y-axis is f of x and x-axis is represented by x here. Okay, now first of all look at the vertical asymptote, x equal 4. So 4 is positive, will be somewhere here because this point is obviously 0. This is 4. Okay, now vertical asymptote, so draw a line like this here. Okay, now f of x equal positive 2, that is your horizontal asymptote, so that will be somewhere here. It's a rough graph, so I'm just assuming it's somewhere here, okay? This is 2. Okay, so this is now the center for the new graph, okay? Now a is vertically stretched more than 3, so more than 1, so it is 3. Now let's see if how the graph will look like. First of all, the graph will look like this, right? Now because a is more than 1, so it will be stretched vertically. So when you say stretch vertically, it will be stretched like this. It will be stretched like this. Okay, yes, now almost close enough. Yep. Also you can draw the graph, this one in the Desmos, and you can see how approximate we got. So this was the original graph. Because of stretch, it will look like this, okay? So that's how you graph it. Now what will be the domain and range now? Now if you look at the domain, okay, the domain is simply, look at the vertical asymptote. The graph is represented at x-axis, okay? So domain is for x-axis and range you look at y-axis. So the domain will be all real number of x other than x not equal 4, because at x equal 4 the graph is discontinuous. You can see here there is no graph at x equal 4. It is approaching towards 4, but since the vertical asymptote at x equal 4, it is approaching but not touching the x equal 4, right? So the domain is all real number of x other than 4. Now what will be the range? Now range is all values of x, all real number of f of x other than x, other than f of x not equal to, other than f of x not equal to, right? Because here if you see, at x equal to, the graph is approaching but not exactly meeting at 2. Similarly here, at this horizontal asymptote, the graph is approaching but not exactly meeting 2. So that's how you do the information. Okay, now let's try one more example, and now I will speed up the information. Okay, since now I was doing it slowly, and if it was slow for you, you can speed up in the video, and if it was fast, then you can slow down. But now I will speed up. Okay, the next question we have, f of x is equal -2 over x minus 1 plus 4. First of all, what is your vertical asymptote? X equal 1, because 1 minus 1 0. This is your vertical asymptote. K equal 4, or f of x equal 4. That is your horizontal asymptote. HA horizontal asymptote, VA vertical asymptote. A equal -2, so the graph will be reflected across x-axis, also stretched, reflected and stretched. Okay, now if you want to write domain here, the domain is without graph. Okay, all value of x other than x not equal 1, because at x equal 1 vertical asymptote, what will be the range? The range will be all value of f of x other than f of x not equal 4, right? Okay, now let's try to draw the graph. This is your x-axis, this is your f of x. Now vertical asymptote x equal 1, so this is 0, somewhere here is 1. Okay, now k equal 4, so somewhere here 4. Now the graph will look like something like this, right? Okay, now because of -2, the graph will be reflected. So this is down, this will go up, and since it is +2, so it will be stretched also. So reflected and stretched, reflected and stretched. So that will be your final graph. Remove this. Oops. Okay, so this will be your final graph for this function. So that's how you will do it. So that's it for the video. I will write one question for you. You can try that by yourself. Also, you can do all this in your Desmos. Okay, so open the Desmos in the Google. Try to write this function in the Desmos, this function, and see if you are getting approximate graph like this. Okay, the next question I'm writing for you is f of x is equal 4 over x minus 5 minus 6. Try to draw this graph by yourself. Write domain, range, horizontal asymptote, vertical asymptote. Yeah, find these all 4 information and graph this function. So that's it for the video. I hope you understood, and please watch the video again if there is any problem. That's it.